In this video, we'll be looking at Venn diagrams. Before I continue, I would like you to subscribe to this YouTube channel and hit the notification bell to get updated for upcoming videos. When we are talking about the Venn diagram, we are talking about a pictorial representation of sets. We can also demonstrate union of a set, intersection of a set, complement, disjoint, or whatsoever. We can explain that. We can use a diagram to represent them. So there was this certain man who sat down and he was like, isn't there a better way to represent sets? Is there a way to make this sets theory look more practical and real? And that was how he came about the Venn diagram. And this certain man name is who we call John Venn. He was the one that brought about Venn diagrams. So we're going to look at some of the set operations that we can illustrate using Venn diagrams. The first one I would love to illustrate using Venn diagram is the union of a set. Like I said from one of our previous video, that the union of two sets actually talking about joining the elements that are in both sets and bringing them together without actually repeating any of the elements. So using a Venn diagram to illustrate this, let's say we have a set A and B. We want to illustrate this using a Venn diagram. We have it to be let's say this is set A and this is set B, enclosed in the universal set. So this is our set A, this is our set B. Now it is enclosed in this set. Remember, we can also use this to illustrate universal set. So the union of this set is just by shading everything that inside, everything you can find, body, everything. So this is actually A union B. We can also use three sets to represent this. We have it to be we have three circles. So we have set A, B, and C. Then we have our universal set. So the union of this set can be illustrated by shading everything inside of these circles. Everything inside these circles. So this is A union B union C. The second thing I would love us to illustrate using the Venn diagram is the intersection of two sets. Now the intersection of two sets from our previous video is actually talking about what they have in common. What can you see in A and what can you see in B? So let's illustrate this with a Venn diagram. We have intersection of A and B first. A intersection B. So using our Venn diagram, let's say this is our set A, this is our set B. A and B, all enclosed in the universal set. So the intersect is actually talking about what they have in common, which is this particular area. This area is the intersect of these two sets. Now, what if it is involving three sets, set A, B, and set C? So we have to look for where the three circles meet each other, where they intersect each other. So these are universal sets. So we have A intersection B intersection C. So it's actually this area, that's where they meet. That's what we call the intersection of two sets. So the third operation we have here is what we call disjoint of two sets. And when we are talking about disjoint of two sets, we are actually referring to what they don't have in common. Okay, they don't have anything in common, just like their intersect is null, is empty. We have explained this in one of our previous videos, so you can look back or check for it as a reference. So using the Venn diagram, we have to represent this. Just let's say set A and B are disjoint sets. So you just have to draw two circles that are not joined together, that are separated from each other. So this is actually the disjoint set. Let's say this is set B and set C, and we have our universal set. So this is just a simple way, or the only way, of representing disjoint set. They are never joined together. The fourth thing I would like us to represent using the Venn diagram is what the elements, the complement, sorry, of a set, the complement of a given set, or two or more sets. It can be their intersection, it can be their union. And when we are talking about the complement of a set, we're talking about what is in a universal set that is not in a given set. So let's say we have set A, illustrating using a diagram. We have set A, and set A has its complement. Okay, so let's say we have a set like this. This is set A, and this is inside the universal set. So now every other empty area, this part, is what we call the complement of the given set A, because it's not found, the elements of A are only found inside this circle, but everything other thing that is outside the circle is the complement of A. So this is A complement. Okay, let's draw a scenario whereby it is involving two elements that have something in common. Let's say this is set B and set C, enclosed in the universal set. Now the complement of these two sets, the union of these two sets, is this. So this is what we illustrate as B union C complement. What about the complement of their intersection? How will it look like? We have it to be, this is their intersection. This is intersection between A and B inside the universal set. Their complement will be this. Everything that is outside this their intersection is what we call A intersection B complement. Thank you for watching this video, and do not forget to subscribe to this YouTube channel to